Hello everyone, I am Akshat Joshi and in this video we'll be discussing MITM Script Injection Attack. This will be divided into three subsections. The first will be MITM, where we'll see what exactly man in the middle is. Then the second section will be script injection, wherein we'll be seeing how we can inject malicious script files to exploit victim data. And then finally we'll be seeing a combination as to how MITM and script injection works in sync. So let's move to the first section, which is MITM. And for understanding man in the middle, let's say there is a device which wants to access some resource over the internet. So what this device will do is, since it cannot directly communicate over the internet, it needs some kind of gateway in its local network to do it for the PC. And hence this gateway or the router will be sitting there in the local network. So let's say in their local network, the router and the PC run on these IP addresses. Now whenever DHCP configures a PC on a network, it also provides it with a default gateway address, and hence this PC will know that its gateway's IP is whatever the IP of the router is. So now in a typical communication flow, what will happen is, when this PC wants to access something over the internet, it will generate a request and send it to its gateway. The gateway will forward the request and take care of the communication over the internet, will fetch a response, and this response will be sent back to whichever IP address generated the request to the gateway. So this is a typical communication flow. Now let's disrupt this and introduce an attacker in between. Now since this attacker will also be a part of the network, let's imagine that this is his configuration. His gateway will also be the main gateway of the network. And now for the execution of MITM, let's say the attacker performs some kind of attack, say for example a ARP spoofing attack, wherein what he does is he changes the gateway address of the victim. So now to the victim, the gateway will be the IP of the attacker. And hence for the next time whenever the victim wants to access something over the internet, it will generate a request and send it to its gateway address, which is the address of the attacker now. Now this attacker will forward the request to its own gateway, which is basically the router, and this part of the communication remains the same, but now the router will send the response back to the IP that gave it the request, which is the attacker in this case, and then the attacker will finally send the response back to the victim. So like this, right in between the victim and the gateway, there sits an attacker who has control over all requests and response, or basically all incoming and outgoing traffic of the victim machine. And this is the setup of a man in the middle. Now let's take a look at the second concept, which is script injections. Script injections are a web application based vulnerability, and hence to understand these we need to take a deeper look at how web applications work. So let's say there is a web app or a website hosted somewhere, and this hosting has to be over a web server somewhere over the internet. So let's say there is a client who wants to access this some kind of web page from this server. The client will generate a request, something like a GET request, and the server will generate a response and send it back to the client. Now what happens is, this response on the client's end will be processed or rendered by the browser, and the browser is only able to understand one language, which is hypertext markup language or HTML. Hence all communication from the server to the client takes place in HTML. Now there is a very interesting concept in HTML which is called the script tags. Inside of these script tags in HTML we can write scripting instructions which can perform various tasks, and these tasks are something like sending user session and cookie details, manipulating information on the server, bypassing validation, and a lot more things. So what happens is, sender, user session and cookie details, these are very important details and very crucial details for things like session hijacking to be done. And then manipulation of information on the server level is again something which should only be done in case the server knows what is happening. Hence all scripts that are executing and performing such activities should be scripts that are already present in the server, which means something like the HTML code that is hosted over the server should be the one that is executing such scripts. Now as long as that is happening, as long as all scripts being executed are initiated by the server itself, everything is fine. The issue starts when the same thing can be initiated from the client side, which means there is some vulnerability somewhere in the code which allows somebody to inject scripts that can be executed on the server level, but the code isn't present there on the server already. And such a vulnerability is called a script injection. So let's say there is an attacker who's found such a vulnerability in one of the web apps. What he does is he injects the script code, malicious script code, and with the injected code he sends the URL link or some kind of link to the victim. Now what happens is when the victim clicks the URL, the victim will send a GET request to the web server, and since this GET request will be infected with the script will get executed on the server side and will perform whatever activity. Say for example, in this case, it may manipulate the information. And now what will happen is, to the server, this request was sent by the victim, and hence the manipulation of information will also take place for the victim. And finally the server will send a typical response back to the victim, and since this will be a regular working of the web app, the victim won't be suspicious of the fact that there might have been some activity that has taken place on the server side. The problem here is that without the knowledge of the victim, his information on the server has already been manipulated. And this way, script injections are a very serious attack that are supposed to be taken care of. Now what happens is, for a script injection to be executed, there are two requirements. First, the attacker needs to find a vulnerability in the client side such that he is able to inject scripts. The second is that once the script is injected, for a victim to execute the script, he has to be dumb enough to click on a suspicious link that is sent by a random user or sent by a random person. And since in today's date there's a lot of awareness related to all of this, it is very unlikely that such an attack is successful. And hence, to cater to this, we have a combination of these two attacks, wherein we'll see how MITM helps us with performing script injections. So let's imagine a typical setup of a man in the middle, and here, instead of the attacker finding a vulnerability and injecting a script and then giving it to the victim, this time what will happen is the victim will have his own intent to serve something over the internet. So say for example, the victim wants to access some kind of web page, so it will generate a request, send it to its gateway. The gateway in this case will be the attacker, and the attacker will forward it to the main gateway of the network, which is the router. The router will communicate over the internet, and when the communication with the web server is happening, there will be a response which is generated, and it will be sent back to the router. This router will send this response back to the IP that generated the request to it, which is the attacker, and up until this point, all of this is still just a man in the middle. Now, instead of sending this response back to the victim as it is, what we'll do is the response that has been generated by the web browser in the form of an HTML, we'll infect that code with a script injection now, and then we'll forward this response back to the client or the victim in this case. So here the two limitations that we discussed previously are overcome, because the attacker doesn't necessarily have to find a way to inject script in the client side, because here the code is being injected on the response that is sent by the server. And the second thing is that the victim in this case is lesser likely to be suspicious, because the request is being initiated by the victim himself, and he is receiving just a simple response from the server side. So to it is a typical response that the server would ideally send. And hence, since there is lesser chance of suspicion, that it is more likely that this attack is successful rather than a typical script injection. And with all of these understandings in place, let's now move to the demonstration. And in the demonstration, we'll be taking a look at two tools. The first one will be Bettercap, which will perform ARP spoofing and which will help us implement MITM. And the second tool will be MITMProxy, which will help us inject the script on the victim browser. And so let's get started with it. So for the demonstration of this attack, what we're going to do is that I have my Kali machine set up here, and this is going to be the attacker, and the victim is going to be my host machine, wherein what I'll do is I'll start the web browser, and let's say we'll have some Google link open here, and this is the first thing that we're going to check, so let's keep that handy. And now what I'm going to do is, on my Kali machine, I'll go to the browser. So on my browser, what I'm going to do is I'm going to look for MITMProxy download and go to the first link here. Now on this link, we're going to look at the latest version, which is 9.0.1. And since we're using a Linux system here, we're going to download the .gz file. So as you can see, the download has started, and we'll continue once this completes. So as we can see, the download is complete, and now we can close the browser and we can go to our terminal. So on this terminal, first let's switch to our downloads folder and let's see if our file exists here. And now we'll move this file to our default location of the user, that is Kali, and this will require a password. So now if we do an ls, we won't find anything here, and if we do a cd dot dot and do an ls now, we find that our file is now situated here. So to unzip this, what we'll do is we'll write tar -zxvf and then the file name, which is MITMProxy, and with that it is able to extract all three files. So now we can do an ls to see that all of them are here, and then finally what we'll do is we'll remove the main tar file. So now we can see that we have our tool set up, and what we're going to do is first we're going to make sure that we are connected to the same network as the victim. So in this case, our victim, which is the host machine, is connected to the student network, and likewise our Kali machine is also connected to student network. So since they are on the same network, what we're going to do is let's clear the terminal and let's get root access on this. And now we're going to start up our Bettercap in order to perform ARP spoofing and implement MITM. So on Bettercap, what we'll do is we'll initiate net probe to see which all devices are connected on the network. So for the time being, it has only one device that it can identify, which is going to be our target. So since I already found my target here, I can turn the net probe off. And now we're going to set up some ARP settings. So we'll say set ARP.spoof.full duplex true. Then we'll set ARP.spoof.targets and then the IP address of all targets. In our case, it will only be one, so which is 192.168.43.114. And now what we're going to do is we're turning on the spoofing. And amazing, so now we are the man in the middle for our host machine, and now that that part has been successfully implemented, we'll start up another terminal. And here what we're going to do is we're going to again, let's start with root access, and if we do an ls here, I see MITM web here, which we're going to start up. Since this is a script, all we have to do is /MITM web and it will start executing. So as we can see, it executes, but it is listening. The proxy is listening on the port 8080. While the problem is that on our host machine, the requests are going from the port 80. So hence we have to redirect all traffic of our port number 80 to our proxy server. And first let's close this, which is the listener that the MITM web opened. And now let's close the proxy, and what we're going to do is we're going to say IP tables -t, which is the table name, is going to be NAT, and we're going to list everything out. So as we can see, for the time being, there is no rule that has been set right now. So what we're going to do is we're going to set a pre-routing rule. So we're going to say IP tables -t net. Then the rule that we're going to set is pre-routing. It will be set over the protocol TCP, and we'll be performing a redirect. The redirection will be all requests that have the destination port set as port number 80, and the redirection will be to the port number 8080. So with that we have the command in place, and now if we try to check the rule again, the IP tables again, we can see that we have added a redirect rule here, which will redirect TCP traffic from port 80 to port 8080. And with that said, what we're going to do is, now we're going to restart MITM web. So we'll say /MITM web one more time. And now this will boot up a listener on the port number 8081, which will help us see our web interface, which started earlier. So as we can see, we have our listener here, and it is able to show us all the requests. So what is going to happen is, let's say for example the victim machine generates some kind of request. So we are able to access the page on the victim request right now, but what is happening is that we are able to capture all of the traffic that is going on the victim side. And now we can add an interception rule based on multiple aspects, like what we are looking for is the response body. So we're going to filter traffic based on response body, and for any request, if the response contains /body, which basically all responses will, so this way what we're going to do is, we're going to intercept all requests whose response contains a /and body tag. So now what happens is, if the user tries to reload this page, the user is stuck on loading because this request over here on the proxy has been intercepted. And now what we can do over here is that on the response, let's say on the response, what we're going to do is, we have the option of editing the response, and we'll scroll down to the absolute end. After body, what we can do is, we'll inject script tag here, and in between the script tag, let's start with a very basic script which will just alert something on the screen. So let's say it will alert something like script injected here. And once we're done with this, what we can do is, we can click on done over here, and then we can resume the traffic flow. So on the victim side, we can see that the script got executed when it got rendered by the browser, and here it is being implemented and the alert is showing. So with all of that in place, the issue here is that till the time in this interface, on our proxy interface, when we are editing and sending the response, all that while here the screen will be stuck on loading, which may make the victim suspicious, and because of which what we're going to do is, we're going to automate this process. And for that, we are going to first close the listener, then we're going to stop the proxy, and now instead of starting up MITM web, we're going to start up MITM dump. And let's start with the help menu of this to see how exactly this settings take place. And in here, basically what we're going to look at is modifying body. We have a /b option which will replace pattern. It will identify a flow filter, and based on the flow filter, we will have some text that needs to be replaced, and the text it is going to be replaced with. So this is somehow the exact same thing as we were doing on the interface. This part, the flow filter, is the -bs, -bs. The regex is the /body, and the replacement will be whatever we put in place of it. So let's see a practical demonstration, and in this what we're going to do is MITM dump -b. we're going to use the delimiter colon, and the first thing, and the MITM dump does not have a /bs, it instead has a /s, which is the same target, as in it filters the response body. Then it will look for the /body tag in the response of the request, and what it will do is it will replace that entire thing with a /body closure. Then we'll have a script placed in it. The script will alert something here, automated script injection, and then finally we are going to close the script and then close the opening bracket. So with all of this set, we're going to run MITM dump now, and let's see what this does. Now on my PC, when I try to reload this request, I get the automated script that was injected, and this time it did not keep loading. So again, the script will get executed as it is, and then since it will not take up time in loading, it is lesser likely for the victim to be suspicious here. Now finally, the thing is that as of now what we are doing is we are injecting all scripts that are indeed JavaScript. What we can also do using this tool is an advanced script injection. So let's stop this, and now what I'm going to do is I'm going to show you a file which is a Python script. And what this does is it enables this Python library, Python interpreter, and then from the Python interpreter it imports MITMProxy, and it has a response that it will send. And in this response, what we're going to do is the content of the response will be replaced, as in the content of the response will be the replaced content, wherein we are going to look for the body tag and replace it with this script. So now what is going to happen is, indeed we are also injecting JavaScript only here, but doing this with Python enables a lot more options than JavaScript alone does, because Python is a very strong and very powerful language. So now let's first exit out of this and let's see how this runs. So if we do a ./MITM dump with a /s, which is a script tag, and we offer this script and run it, so it will start up a proxy server at port 8080, and once that is started to listen, we can go back to our victim, and if we reload this page now, we'll see that the Python script injection has been executed, and this will keep continuing on every response we get, because almost every response is supposed to have a ending body tag. So this is what MITM script injection does, and I hope this video was informative and interesting. Thank you so much. We'll meet again.